Thank you, everyone. I welcome all of you to a webinar presented by CIGNEXDatamatics, MongoDB with RDBMS for portal applications. Good morning to the attendees in UK and good afternoon to the attendees in India. And in the next 40 to 55 minutes, we will talk about how MongoDB was coupled with RDBMS for portal applications. And Nikhil Naib, who is the senior architect, big data solution architect, he has put together a nice presentations with a lot of best known methods and practices which you all can benefit. So once again, I welcome everyone to the webinar and I thank you for your time. Before we start, I just want to introduce CIGNEXDatamatics as a company. CIGNEXDatamatics has been in the business since 2000. And our main focus has been open source solutions, which is enterprise solutions where companies are looking to adopt open source. And that's our main focus. It's been 15 years, and over the 15 years, we have developed 500 plus open source solutions deployed across 200 plus customers in 15 countries. Completely, we are a pure play open source solutions company. We have a total employee strength of 500 and all of them are focused on the open source solutions. And the solution that we focused on: portals, content collaborations, enterprise content management, big data analytics and Internet of Things, and e-commerce. As an open source, every year we have been publishing a book on open source. So 14 books we have published, and there's a 15th book which is coming out in December. And there are business engagement platforms that we have developed which are more easy to deploy and it can be customized further for the customers. So there are a couple of platforms we have developed on big data and IoT, and 3 platforms we have developed on the system of engagement overall. Nikhil Naib, who is the presenter, he is a big data solution architect. He has been with CIGNEX for the past 5 years. Overall, the industry experience is 12 years, and at CIGNEXDatamatics, Nikhil has worked on 7 to 8 projects that are part of our big data solution practice. And today in the webinar, he will be talking about one particular project implementation where how the MongoDB was implemented or considered as an addition to the RDBMS with certain business objectives. So I take pleasure in introducing Nikhil Naib to all of you, and absolutely would like to make sure your time is used to the best of knowledge, and that's exactly what Nikhil will talk about in next 30 to 40 minutes. Please feel free to ask us questions during the presentations, and we will take questions at the end of the session. With that, I would like to ask Nikhil to take us forward with the webinar.
Thank you, Neera. Thanks a lot for the introduction. So good morning to the audience from the Europe region, and good afternoon to the people from Asia region. First of all, I would like to thank all of you for joining us today for the webinar on using MongoDB with RDBMS for portal solution. I would like to take this opportunity to share our learnings and experiences we had while working on this large-scale enterprise class solution for boosting its performance and scalability many folds, and addressing the key compliance issues that this application was facing regarding the data privacy. With this, let us look at the topics which we are going to cover in today's webinar. In today's webinar, we will be looking at the key challenges of the enterprise portal application, and then we'll be also looking at the MongoDB, the NoSQL database, the leading NoSQL database, and then we will be looking at the case study in detail on a global e-learning platform for which we have worked on this solution. We'll be looking at the solution architecture, the approach, and the best practices that we have learned. While doing that, we'll be looking at the storage engine, the schema design, the data migration, sharding, performance monitoring, and other measures that we have taken for improving the performance and scalability. And then we'll be also looking at the benefits that we have drawn by using by introducing MongoDB in this application stack. At the end, we will be again looking at the best practices and learning, augmentation of an RDBMS solution with MongoDB, how each one of them can coexist in the same application stack and cater to their respective use cases. and then we will be taking the question and answers. So I hope everyone is okay with the agenda and today's topic. So with that, we can move to the next slide. So first of all, we are going to talk about the key challenges that are faced by an enterprise portal application. So for that, I would like to give some background of the backends that are popularly used by the enterprise portal application. So the portal applications so far have been using the RDBMS technology. So RDBMS technology came into picture in 1970s and was a great fit for the use cases which were basically centered around building a system of records with primary characteristics such as little variation in the volume of data throughout a substantial period, then very predictable growth in the set of users and locality of the users, and then the data being stored had a fixed format with support for a limited set of data types. Also, the data access patterns of the application built using the RDBMS storage was sequential in nature, which was quite suited for the storage hardware, meaning the tape drives and the magnetic disks available at that time. So from that point onward, it became a general trend of using an RDBMS as a primary data store for various types of applications, irrespective of the nature of the use case of the application. This particularly is applicable to the web applications where the dynamics of the data, that is volume, variety, and velocity, are not meant to be handled by an RDBMS type of store simply by the design itself. The general characteristics of any enterprise class portal application in today's scenario are thousands and millions of requests per second. Then the time to market a new feature in application is very less, and it has to catch up with the business, business competition. So most of the portal applications today employ the agile methodology. Also, to scale according to the business need, the data store has to be cloud ready, which gives ability to scale horizontally. For example, an e-commerce type of application needs to handle more traffic during the festive seasons. Also, the consistency of the user experience. If the user happens to move across the geography, happens to move from one geographical location to the other geographical location, the user experience has to stay consistent. It means that the user should not be experiencing any any network latency issues or something like that. To address these challenges, most of the most suitable option for an RDBMS store is to scale vertically. At this point, the business challenges comes to picture. The licensing cost of an RDBMS are per CPU base or per core base, which exponentially increases the cost of ownership, including the maintenance overhead. So if a portal application which has been based on an RDBMS wants to scale, it has to acquire or procure a high-end hardware, and the cost of that hardware will be very high, and then they cannot scale down once the traffic has reduced or something like that. So the application cannot scale according to the workloads. This whole situation essentially needed a technology breakthrough, which came in the form of NoSQL databases in early 2000. The basic design concern for a NoSQL database was the use case and not the storage pattern. So that is, in case of an RDBMS, we have to design the schema up to third or fourth normal form in order to store the data efficiently. So that is not the design concern with a NoSQL database. Also, the NoSQL data stores have been enabled to handle the horizontal scalability, performance, and unstructured data storage by design. So the challenges which were faced by RDBMS data store, they have been mitigated in a NoSQL database solution. So if we look at this slide over here, we can see that the SQL databases, they have only one basic use case, that is they are meant or designed to handle the transaction workloads. And if you look at the flavors of NoSQL database, that is MySQL, Oracle, PostgreSQL, these are very popular SQL databases, but they have a very little variation in terms of the design they employ or the use cases they can handle. So whereas if we look at the NoSQL databases, we can find a variety of the NoSQL databases in terms of the use cases they can handle. They are document-oriented databases, key value stores, wide column stores, graph database, document databases that we have today. The popular one is MongoDB. In key value stores, we have Redis and React, and in wide column stores, we have HBase. For graph database, we have Neo4j and Giraffe. If we look at the schema design pattern, then the SQL database basis, we can design schema optimally just by confirming up to third normal or fourth normal form. Whereas in NoSQL databases, the schema design is entirely up to the use case or the access patterns of the application or the production workloads of the application. So in NoSQL databases, the schema design is completely dynamic. And if we look at the scalability aspect of the SQL databases, then in RDBMS, the only way to scale is to scale vertically. That is by procuring a very high-end hardware. Whereas in NoSQL databases, we can scale horizontally even with the help of a commodity hardware. So the cost of scaling in a NoSQL database is very less as compared to a SQL database. Now let's look at the data querying or data access facilities that are provided by the SQL databases. In SQL databases, we have to write queries for each of the select, insert, or update operations, that is the CRUD operations. Whereas NoSQL databases provide a uniform object-oriented API interface, which is very easy to use. At least that is the case with MongoDB so far. Now, for the current use case of the portal solution, the right type of the NoSQL store is a document-oriented database, which provides features such as dynamic schema, rich data types, and high availability and horizontal scalability. And while looking at that, at CIGNEX, we have a very good experience with MongoDB, which readily provides these features. So MongoDB is the fastest evolving and leading open source NoSQL database in the world today. It has been downloaded more than 5 million times and has been used by most of the Fortune 500 companies for a variety of the use cases. It is available in community, professional, and enterprise versions. With version 3.0, MongoDB has introduced support for WiredTiger storage engine, which provides up to 3 to 10 times better write performance and ability to compress data up to 80%. MongoDB provides excellent support for horizontal scalability and provides the ability to have up to 50 members in the replica set for providing high availability. With features such as deployment automation, one can easily add an extra node to the replica set or even a replicated shard very easily. The deployment automation feature is very excellent in order to scale on demand and also provides ability to perform version upgrade activities very seamlessly. So now let's look at the augmented portal application database with MongoDB. MongoDB has already been used by many big customers of us for portal and content collaboration in enterprise content management. We have also used MongoDB for big data and analytics and in e-commerce portal. So in an augmented database architecture, both RDBMS and MongoDB can coexist, addressing their respective use cases. RDBMS are basically, designed to address the transaction-oriented use cases which exist in many of these cases. Say for example, in an e-commerce portal, an OMS, order management system, is still a transaction-oriented system. So MongoDB has proven track in all of these use cases such as portals, analytics, e-commerce, and enterprise content management. MongoDB is also completely cloud ready and can be easily deployed on cloud-hosted environments such as Amazon AWS. Thus MongoDB helps to scale on demand as per the business needs, and which proves to be very cost-effective approach, wherein we can provision additional infrastructure or trim down as we go. So at CIGNEXDatamatics, we have been working on MongoDB for past 4 years, rather more than past 4 years, and built a variety of use cases and products around it. We have developed applications providing 360-degree view, single 360-degree view of customer, employees, partners. Then we have built applications on Internet of Things, which is very popular these days. Then we have built products around reputation management, social listening, content management and delivery, the product catalog, and user data management. And in today's webinar, we are particularly going to focus on the user data management and content management delivery aspect. Also, I must not forget here to mention that we have experience on working with customers spanning from startups to multi-billion-dollar revenue. So which gives us a great experience, with working on variety of customers and on variety of use cases as well. So now let's talk about the case study, that is global e-learning platform. So in today's webinar, this is the case study which we are going to look at, and we are also going to see how MongoDB as a NoSQL data store has helped to achieve efficient user data management and to comply with the data privacy laws of different regions such as North America, Europe, etc., and also help to achieve 5 times improvement in the performance as well. So with that, let's start looking into it, so let's take a brief client overview. Here the client is a large networking company which designs, manufactures, and sells networking equipment. The corporate affairs division of this company invests in self-sustaining and scalable technology initiatives. In this, the corporate social responsibility program of this corporate affairs division has built an e-learning portal which offers IT skills and career building programs to the institutions and individuals spread across the globe. It has more than 2 million students, 20,000 plus instructors, and it has conducted 146 million online exams so far. So now let's look at the challenges that this application was facing, and how augmentation with MongoDB as a NoSQL data store is helping the application now. The challenges that the application was facing with an RDBMS type of primary data store was specifically related to the performance. In RDBMS, the schema was very highly normalized. So for fetching data, or for fetching data for even country, state, and city, or something like that, even the location-oriented data or some course-related data, the application was issuing queries to the database with joins of up to 4 to 5 tables containing millions of rows. So because of that, the performance was getting severely impacted, and the response times were ranging from 6 to 16 seconds. So this was causing a very bad user experience. Then in terms of the scalability, the application was not able to scale from the backend standpoint. The client was able to sustain in only one data center. So because of that, the users were from the different geographies were also facing the issues related to the network latency. So the complex queries which were issued again were causing the table locks in many cases. So the database was automatically getting slowed down, and because of this highly normalized schema, the various join queries were consistently being issued to the database, and it was the database was becoming a bottleneck to the performance. So after identifying all these issues, we proposed an augmentation with MongoDB, and which is basically a document-oriented database with dynamic schema supporting many data types. So we did not face any issues regarding porting the data type from an RDBMS to the MongoDB, as most of the data types were readily supported in this case. Also, MongoDB supports tag-aware sharding, which facilitates geo-awareness, so that which helped us a lot to comply with the data privacy laws of the regions such as Europe and US, and it also helped to reduce the network latency which was experienced earlier by the users of this application because the single data center hosting of the database. The application replication and sharding feature supported by MongoDB helped a lot to leverage the horizontal scalability and high availability. So with this, MongoDB provides facility to scale on demand and scale easily with the commodity hardware, and it also supports replication, which helps to leverage the high availability. And MongoDB has also introduced a very highly optimized storage engine in terms of WiredTiger, and it also supports, MongoDB also supports embedded documents with the help of which we can store the data in a denormalized form, which helps to reduce the number of join queries that that were being issued to the database. Now let's look at the new augmented architecture. Earlier we did not have MongoDB in the stack, and Liferay was directly interacting with the PostgreSQL database. So we had Liferay portal application server and PostgreSQL server as a part of the application stack. We had to change this stack a little bit in order to support MongoDB seamlessly without interfering with the current application workload. So we decided to go ahead with a REST-based services approach built using Jersey and Java. And this REST-based services were interacting with MongoDB and were fetching the data and inserting the data to and from MongoDB from the Liferay application code. So this helps us a lot to keep this architecture loosely coupled, so that tomorrow, if the need arises, we can completely switch off this REST-based services and keep interacting with the PostgreSQL database. So this backward compatibility was achieved with the help of this REST-based services approach. So with MongoDB 3.0, MongoDB has come up with a pluggable storage engine architecture in which with which it provides an ability to have these different type of storage engines according to the application workloads. So in 3.0, it provides support for mmap-v1 and WiredTiger and in-memory storage engine. In-memory storage engine is in experimental mode and is not suggested to use in production, whereas mmap-v1 and WiredTiger both have been declared as fit for production. So currently, the supported storage engines are WiredTiger and mmap-v1. mmap-v1 is more suited for the read-heavy workload, whereas WiredTiger is more suited for a balanced workload, that is mix of high read and write workload. So WiredTiger can cater to both type of workloads equally, whereas mmap-v1 is more suited for the read-heavy workloads. So after looking at the feature set and the applicability for the use case, we decided to use MongoDB 3.0 with WiredTiger storage engine. With WiredTiger storage engine, MongoDB provides document level locking, data compression up to 80% with snappy algorithm, and up to 90% with zlib. It also provides 7 to 10 times higher throughput in terms of writes than the previous versions. It also provides ability to saturate CPU cores, meaning here the WiredTiger storage engine is more CPU bound than mmap-v1. All the modern CPUs, all the machines are having more cores per CPU. So the mmap-v1 was not fully able to utilize this ability, this feature earlier. So MongoDB has provided the WiredTiger storage engine which can fully leverage and saturate all the cores of the CPU. And with WiredTiger storage engine, we can store indexes and data on separate mounts for the optimum utilization of IOPS. So for quick retrieval of data, it is highly imperative that the indexes reside on a mount which has more IOPS power. So we can provision or store the indexes separately from the data on a mount which has got more IOPS or provisioned IOPS. So the WiredTiger storage engine is 100% backward compatible, and the upgrade to 3.0 is completely non-disruptive, and we do not need any downtime for this migration process. The best practices that we would like to suggest over here are that please use XFS file system with WiredTiger, as there are known issues with WiredTiger on ext4 and ext3. So we learned this lesson hard way. So we would like to suggest this upfront to you guys, so that you do not face this one. Please ensure that you are staying up to date with the minor version releases of 3.0. This is very important because most of the fixes are pertaining to the WiredTiger storage engine and sharding. Please look at the minor version releases given by MongoDB for 3.0 release. The latest one is 3.0.6, which also has fixes for WiredTiger storage engine and Sharding. So now let's look at the schema design approach that we followed for designing schema for MongoDB, for migrating the RDBMS tables to MongoDB collections. So we first try to understand the functionality of each and every library portlet. We started with the custom portlets. The default built portlets of the library were kept as it is, so that we do not disturb the core functionality of library, and the custom portlet can be easily migrated and plugged out from the library ecosystem. We also understood the external data points and the nature of data. So there were third-party APIs that were being used for capturing the data from different sources. So we understood the nature of those data and how we can ingest that data into MongoDB, so that we do not come across any data type compatibility issues. We also understood the RDBMS schema design, including each and every table and the field data types in the existing RDBMS schema. We understood the queries covering all CRUD operations, along with triggers, views, cursors, stored procedures that were used, and we also tried to find out the workarounds that we can use in place of the stored procedures and triggers, which are not readily supported in MongoDB. These features are not readily supported, so we have to look for some out-of-the-box support or some workarounds that we can implement in the application code, or some JavaScript code that we can write on the MongoDB server-side JavaScript code that we can write. So with the help of this, we created a schema of MongoDB collections. Now let's look at a very simple portlet. That's the location list portlet, which is a custom portlet that we had built in library. So it has basically three tables: location country, location state, and location city. So for fetching a complete information regarding the user location, query involving join with three tables was being issued, and a location city table contained more than 2 million rows. So this was causing a lot of performance issues, and loading even the country, state, city drop downs in a few of the cases was taking more than 5 to 6 seconds. So we created a denormalized schema in Mongo, which has been displayed on the right hand side. And over here, we also made use of the sparse indexes feature provided by MongoDB, and we tried to ensure that the queries that we write in Mongo are covered queries, so that we do not hit disk again for fetching the data, and the queries can be fulfilled just by looking at the index itself. So now let's look at the best practices and learnings that we have had while doing the schema design for Mongo. Do analyze the data access patterns of the application. It's the starting point from where for introducing Mongo into the application stack, because unless you understand the data access pattern fully, you cannot leverage many of the features which are provided by MongoDB. You have to define indexes by identifying the common queries. So creating an index on the collection, introduces additional overhead for writes. happening on that collection. So please keep in mind that lesser the number of indexes on collection, better the write performance for that collection will be. Also, please ensure that you do not create any duplicate indexes because the indexes can use the leftmost prefix readily. So in case of a compound index, the left prefix is already available for use as a separate index. So use explain method and MongoDB profiler for query optimization. These are the best tools provided by MongoDB, which can very well help to identify the performance bottlenecks well in advance. So please make use of these tools. Create the collections to denormalize the schema for optimal performance. This is also very important, because if you create separate collections, and then you will be moving the same set of problems which were there in an RDBMS structure to the Mongo schema. So please try to denormalize as much as you can, so that the number of joins can be reduced and the data can be fetched with a single query itself. So, and please remember that if the number of indexes on any given collection are going beyond 10, then please reconsider the schema design for that collection. If required, you can move few of the fields from that collection to a separate collection. So please, and also remember that there is no support for transactions in MongoDB per se, but there are workarounds available, and here is a link for those workarounds. So the approach that we followed for migration of data from RDBMS to MongoDB using an ETL tool. Here is a brief description of that. So we created SQL queries for migration scripts. We also identified a good MongoDB Java driver for interacting with Mongo and talking to a PostgreSQL and also driver for talking to PostgreSQL database for fetching the data. And we leverage the multi-threading feature provided by Java to its optimum so as to reduce the ingestion time and the insertion time. The bulk API feature provided by MongoDB helps a lot to reduce the total ingestion time and also to reduce the migration time subsequently. Also, if possible, please try to host the RDBMS instance on a fully read optimized instance in which all the switches and knobs are completely turned in favor of the reads, so that the migration time can be reduced. So as mentioned earlier, with MongoDB you can use bulk API feature of MongoDB for bulk ingestion of data, and you can reuse the existing infrastructure for migration scripts deployed as the servers which will be used for services. The services will be open afterwards, so that that infrastructure can be readily used for execution of the migration scripts, which will interact with both Mongo and PostgreSQL. And also try to ensure that the migration process is fully fault tolerant, and this process should only begin from where it had left and not from scratch. This is very essential, because even if there is a small glitch in the migration process, and the whole migration process has to start again from the scratch, then the migration activity can definitely not be completed in the given migration window. The migration process has to be built in a fault tolerant way. And also try to ensure that the auditing is happening for the entire migration process and all the data is fully migrated within the migration window only. And I would also like to suggest to do a dry run of the entire migration process so that if there are any issues, then they can be anticipated well in advance and can be addressed. Now let's look at the sharding. We implemented the tag-aware sharding approach to bring the geo-awareness to the application data. Sharding or horizontal scaling divides data and distributes it over the multiple servers or shards. Each shard is an independent database, and collectively the shard makes up a single logical database. Sharding reduces the amount of data that each server needs to store, and also each shard stores less data as the cluster grows, and hence subsequently the fewer number of operations on individual nodes will be executed. Now this tag-aware sharding feature was introduced in MongoDB so as to bring the geo-awareness to the application data. MongoDB allows balancing using a tag-aware sharding. The tags are assigned to the shards. The tags created are then associated with the ranges of the shard key. The balancer migrates the tagged data to the appropriate shards and ensures that the distribution of the data happens as per the tags are described. The tag-aware sharding also helps to improve the locality of the data for the sharded cluster that spans multiple data centers. So if there are 3 data centers in which the 3 shards are there, for example, each shard in each of the regions of US, EMEA and APAC, then the users in those regions will be fetching the data in the nearest locality. That helps a lot to reduce the network latency. So here are the few of the characteristics of the ideal shard key, that the shard key should be highly cardinal, it should have higher randomness, and if there is no such natural candidate of shard key in the given schema, then you can create a computed shard key as well. So this is the high-level architecture of the application which has been augmented with the MongoDB, wherein the request comes to load balancer, and then it redirects that request to the respected app servers in the geographies. And those respective app servers also host MongoS and MongoDB Arbiter. And there are 3 config servers. Please always remember that in a production shard, you have to have 3 config servers because these config servers work in a 2-phase commit manner. So if one of the config servers is down, the chunk migration process will be stopped. The cluster will be available only for the reads and writes, but the chunk migration or the data balancing on the shards will not happen. So all the 3 config servers have to be operational all the time in order to work the sharded cluster completely as desired. So here you can see that the app server was interacting with the MongoDB cluster and also with the PostgreSQL database as well, but that interaction was happening through a services layer. which because of the lack of space cannot be shown over here in the application architecture. So the best practices we would like to suggest over here is to plan for sharding very well in advance to ensure that it is tested very well, okay, and you can provision the infrastructure well in advance and test it with production like workloads to see the impact whether the application is giving you the desired throughput or not. Also ensure that the network administration team is involved when you are planning for hosting a geographically distributed sharded application, because these will be your go-to guys if you face any cross data center connectivity issues. We face these issues. That's why we are suggesting to use this route. Also deploy shard router on the application server so that one call over the network can be saved. Those who are familiar with the sharding architecture can understand what I'm saying over here, what I'm trying to say over here, because application has to first call the MongoDB, which is a shard router, and shard router in turn talks to config servers and the respective shard servers for fetching the data. So if the shard router is hosted on the application server itself, then this extra call over the network can be saved. And also remember that the non-sharded collections can be balanced across the different shards so that all the shards receive the same amount of traffic. There is a workaround which has been very well written in the blog by Asya Kamsky, who is a senior solution architect at MongoDB. So you can read that blog post, and also ensure that the indexes fit very well into RAM. If that is not happening, then it's a double whammy for your application, because it has to first do a disk call for the indexes which are stored on a disk, and then there will be a separate call issued for fetching the data, which is again there on disk. And fetching the data from disk is always very slow as compared to fetching the data from RAM. And so you can use appropriate write concerns and read preferences based on the use case. This can be very helpful to reduce the network latency issues. And you can also use the replica set tag sets in combination with the appropriate write concern and read preferences to address the data privacy concerns. So after introducing MongoDB in the application stack, we ran our performance tests with the production workload, and here are the results that we have got with that. So portal dashboard, which was earlier taking 16 seconds in few of the cases, was now consistently taking approximately 3 to 4 seconds to load. User enrollment was taking 17 seconds, which was brought down to 2 to 3 seconds. And user profile also is now taking approximately 3 seconds to load. Most important gain was in search, which was taking approximately 29 seconds in many of the cases. Then consistently started taking up to 3 to 4 seconds to complete. Now let's look at the cluster management and monitoring approach. Now maintaining a sharded cluster and monitoring a sharded cluster is very essential for getting a consistent throughput. So in our case, the sharded cluster was having more than 20 nodes. So imagine if there is no efficient tool for monitoring such a cluster. In that case, it will be a real pain to have such a cluster in first place. So to have an efficient tool for monitoring such as MMS, which has been readily provided by MongoDB itself, it's a great tool to use. The Mongo Management Service has features such as automation, with the help of which you can provision upgrades and scale on demand. You can take backups, and that too, the point-in-time recovery is also possible with the help of these backups. That is, you can recover data and data up to a specific point of time back in history. And it also provides excellent monitoring features and alerting features. It helps you to monitor more than up to 100 parameters, different parameters of clusters. So here is a snapshot from MMS cluster. So the benefits that we have delivered in terms of performance, scalability, data privacy, and lower TCO. So in terms of performance, the web page response time was reduced back from 6 to 16 seconds to less than 2 seconds in many of the cases. The migration of 500 GB plus data was completed in 4 hours. The geo-based tag sharding was used to reduce the network latency, and data now can stay in the respective zones as desired, also to comply with the data privacy issues. And with auto sharding, we can also now accommodate new geographies or new data centers as and when required. If we are required to support a new data center, say in Philippines or in China, we can easily provision that with the help of MongoDB and the tools provided by it. And eventually, it resulted in a substantially reduced TCO. MongoDB by design is open source, and it has a reduced licensing cost and vendor dependency, and the time for development is accelerated, and many of the features are provided by MongoDB out of the box. So what essentially I would like to emphasize again is MongoDB scales and shines. So far we have used MongoDB in more than 7 projects, and in each of those projects MongoDB has been exceeding our expectations. It has been consistently delivering excellent performance. So we would definitely recommend to use MongoDB. I would like to suggest these measures to ensure that MongoDB has been used properly. First of all, identify indexes carefully. The more number of indexes will bring down the write throughput. Plan early for sharding. This is very, very essential. If you decide to shard without testing the shard key, then there will be issues in terms of scaling, because shard key is the single most important component for a distribution of the data in a sharded cluster. So please ensure that your shard key is giving you the desired write throughput and read throughput as well. Do not forget to set ulimit and no a time. These are very small but very important in order to achieve the significant performance gains. Use bulk API of MongoDB. This bulk API feature got introduced in 2.6 in MongoDB and is very useful for bulk ingestion of data, and this will help a lot to reduce the migration time. use Java's support for multi-threading. This is very essential. WiredTiger supports thousands of concurrent writes. So if we make right use of multi-threading support provided by Java, it helps a lot to reduce the migration time. And MongoDB Ops Manager, this can be used to for cluster monitoring and managing the sharded cluster and provision the nodes as and when required. Use SSDs and RAID 10. RAID 10 is very good for achieving the right read and correct read and write throughput for database type of workloads. For SSDs, I would strongly recommend to test with your production workload or your data access patterns, because it is very much subjected to what type of data locality you have with your workload. So SSDs should be tested before they are used in production. And use MongoDB Enterprise Edition. This is again a very important point that I would like to suggest, that MongoDB with Enterprise Edition has come up with excellent support and very high-class security features which are expected in any enterprise class portal. So with this, I would like to hand it over back to Nirav. Nirav, you can please.
Sure. Thanks a lot, Nikhil. In the interest of time, I'm going to be very quick. On this slide number 29, this is where the industry or kind of types of company they've leveraged MongoDB in their enterprise solutions. And the companies like GPS Services Company, where all the devices were transferring data and MongoDB was used for the analysis of the data in the real time. The networking company, which is a video streaming application that leveraged MongoDB. Insurance company, where IBM DB2 was used as a database, but for the performance, it was coupled with the MongoDB. So that insurance company, they were able to reduce their code processing time from 30 minutes to 5 minutes. This is a startup company providing the intelligence, the social sentiment analysis. For the real-time analysis, they leveraged, they ingested the data from the social networks and analyze it, and providing real-time sentiment and trending analysis. Business-to-business marketing intelligence software services company, where they were able to leverage more than 1 million data sources and analyze all them and provide the relevant intelligence to the sales team. So that was the business use case. And e-learning community portal, which is what we just talked about in the presentation. That's where the MongoDB was used. Here is just a quick big data analytics practice that CIGNEXDatamatics has. Absolutely, I suggest you to visit CIGNEX.com and understand more about what we do. We are a MongoDB advanced partner and have been partnered for the past 3 years with MongoDB. Some of the big data analytics and IoT expertise that we have, which you can also find information on our websites. One which I'm going to recommend here, a quick assessment, which is a open source readiness assessment. There are 25 questions, 15 minutes it will take, but it will go through a set of questions for the system of engagement and system of insight. And overall, it will tell you whether the applications that you have, are they customer focused, and what is your level of customer insight. So it's a completely complimentary survey analysis that you will do, and you will get an instant report. So do visit operaonline.cignex.com and you will get an instant report within 15 minutes. If you're thinking about big data, haven't decided, kind of sitting on the fence, would like to look at the big data, then there's a kind of a engage us for proof of concept, where $5,000 we can develop a POC which you can validate in your environment, in your applications, whether the big data technology can benefit you. So absolutely, for that, do drop us an email or visit cignex.com and fill out a form. And here are the website address, CIGNEXDatamatics.com, and you can contact us at info.cignex.com. So that brings the end of the webinar. I would like to please ask us the question. I'm going to read out the questions. So let me start with the questions. So there's a first question. Which ETL tool did you use for data migration?
So for data migration, we used a custom ETL tool that we wrote in Java or here only. So it was a custom ETL tool built by us.
Okay. Second question is, were there other technologies were considered in place in lieu of MongoDB? Did you look at other technologies?
Looking at the use case and the NFR requirements of the application, we felt that MongoDB will be the best fit for this use case. So we decided to go ahead with MongoDB. We also had thought of CouchDB or Cassandra, but eventually we decided to use MongoDB because it was fulfilling all the criteria and compliance requirements and everything. The feature set was very great, is very great with MongoDB as compared to the other products.
The third question is there a possible SQL Server to MongoDB upgrade?
SQL Server to MongoDB, I'll take it as a instead of upgrade, I will take it as a migration. So yes, SQL Server to MongoDB migration is possible. SQL Server to MongoDB upgrade, I am not very sure about. So yes, this migration is definitely possible. So here for this use case, we worked on we took an augmentation approach just for the sake of interest of the client, and so that we do not touch or play with any core features of the portal application, because it has been very widely used. So that's why we decided to take a cautious approach. But there is a definite plan for MongoDB to be a very major component in this stack only. So yes, we can go ahead and replace SQL Server with MongoDB depending upon the use case. So we will need an evaluation for that.
The next question is MongoDB suitable for frequent updates use case?
Yes, with the introduction of WiredTiger storage engine, we can definitely support many number of concurrent write operations. Typical WiredTiger storage engine supports up to 70,000 concurrent write operations in YCSD benchmark.
Okay.
So yes.
So those were the 4 questions. Any last minute questions before we end the webinar? So once again, everyone on the call, CIGNEXDatamatics would like to thank all of you for taking the time out and to attend the webinar. We hope the webinar was a good use of your time, and love to hear from you. Thanks a lot with that. Thanks everyone.
Thank you. Thanks a lot.